All right, welcome back. We're going to look now at the Who2 dataset, which again is another dataset built into the packages that we're using. So Who2, if we call that, this pulls up the dataset that has 7,240 rows with 58 different columns of dataset. And for some unknown reason, uh, to make it particularly difficult or obtuse to understand or comprehend, the data is split. Again, this is tuberculosis data by country and year, and it's split by the diagnosis as one variable, whether they were uh, male or female by the next variable is gender, and then age as the third variable, and it was all input into this data this way to make it particularly difficult to observe or to make it particularly difficult to categorize and analyze this data by combining multiple variables into a single column. So normally, under most cases, you probably wouldn't have to deal with this issue because most of you will be in control of your own data sets. But say, for example, you're not in control of your own data set, or perhaps you're doing some analysis based off of prior work and you come across a data set like this, there are ways that the tidyverse can help facilitate that. So we're going to take our Who2 data, we're going to ask it to pivot longer. So for columns, here's another neat trick, because start with week or something like that is not going to work in this case. We could either give it all of the column numbers, or we could say the exclamation point means not country to year. Everything else, yes, basically. So we have country, year, and then everything else. So I could say, for example, 3 to 58 to give it all of the columns 3 to the end of the data set. Or I could just say not country or year. All of these are equivalent ways of specifying. Uh, if it's me, typically I learn one way and then just always use that one way over and over again. But sometimes it's useful to have a flexible point of view so that your way, when it's not the ideal way, you can modify it so that it works. But anyway, so numbers would work here. Otherwise, you could just say not these columns. This method would be much better if, say, for example, country is listed like somewhere random in your data set, where it would be difficult to figure out what are the correct numbers of column, what column numbers are correct. So you can just name them and just say not these particular columns. But anyway, we're saying we're going to pivot everything except for country and year to a longer format. Then we're going to give it a names to, and what we're going to call, and because the way that the data is formatted is diagnosis, gender, age, we can specify that we want diagnosis is the first one, gender is the second one, age is the third one, and that we want to separate our names by the underscore. So luckily, even though this is a very complicated format, they split everything up by underscores. And if you are creating data sets where you need to combine different things, using underscores, you'll find out pays you back a lot just because it makes it very easy for programmatic or computer separation of them. So even though this is a very complicated data set that would be to analyze otherwise, because they created their three variables with an underscore between them, but actually isn't that difficult. So then we say the values to is going to create a count column. We're going to separate everything by the underscore, and we're going to create our names to as diagnosis, gender, and age. And what this will do is create a new data set where we now have country, year, the diagnosis, the gender, the age. And then we can scroll down to, yeah. Here we are, finally some non-NA data for our count data. So this gives us the actual data that would have been in the number of counts of each of the various occurrences of those particular combinations. Okay, so that is just a simple example of using multiple names to, if you need to separate or split a named column by something else. This is a way to do multiple combinations or multiple, I guess, if you will, pivots in one go. I'd say this is probably not your most common situation unless it's working with data sets that you don't typically have control over. Because normally, if you were going to be the one doing the analysis, you would not make your life difficult like that on purpose. All right. Just as we've been going from wide to long, we can do the exact opposite. So if we look at what we've had before, we can create the data frame that's now in the long format. And let's say we want it to go to the wider format, and we can easily do that. Instead of using pivot longer, we use pivot wider. And then the names from, so we tell it what is the column that will give us our new column names. So in this case, it's measurement. So that we'll have one called BP1 and one called BP2. And then the values from where the actual numbers to put them in will come from the value column. And as you can see here, we end up going straight back to our wide format where we have IDA with BP1, BP2, BP3. This isn't the same data as before, which is why it looks slightly different. And what you can see also is that in my long format, I did not have a BP3 for the, yeah, sorry, this little thing's in the way. I did not have a BP3 for ID number B or IB or IDB, ID letter B, but I do for letter A. So what that ends up doing is that it ends up automatically putting in an NA for that value for BP3 for me. Again, if you look at pivot wider, you could have this change so that it changes this NA to like a 0 if you know that it's supposed to be a 0 value or some other value if you wish. In most cases, NA is just going to be the appropriate one, and that's the default way that it does that. So we could take our same billboard longer data, we could pivot that wider and go back to exactly what we had before. So we have our track, our date entered, and then it gives me columns of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, etc., just like what we had before. But instead of it being week 1, week 2, week 3, week 4, etc., it now just gives it to me as one row of columns. Okay, so now we can go into a variety of different types of helper functions. So if I want, remember distinct as another useful tool that will tell me what are my different values or what are my unique values for something or levels of a category. So I've been using unique often, that's in base R, and I just use that quite often. The tidy version of that is going to be distinct, and that gives you those particular measurements. The poll is just returning this instead of it being a data set. It's now just returning it as a list for me. So if I wanted to do something that was more on a list, like a function that did a for loop, for example, it would now be in a ready list for me. So our DF, we can also take our data frame and instead of doing select like we normally have, where we select particular columns, sometimes it's quite useful to just drop certain columns, where maybe I want all of the columns except for this one, and I can select all of my columns, or I can essentially deselect, if you will. So select will allow for selection or deselection. So if I kept measurement in, for example, and just remove value, it would select multiple ones and then give me my measurement column. So now what it is presenting is what are my distinct values for my measurement column. But I could remove both of these, and instead this way it gives me my ID column. And the reason for that is in the first version, I am deselecting this one and this one, so then it automatically defaults to what's left over. I could also get the same value as if I just selected the ID column, and it would give me the same distinct. You might ask, why are you doing it one way or another? This is because in some cases, it's more useful to just remove a column. Sometimes it's more useful to keep a column. If I just remove measurement, it does the distinct combination between ID and value. So it gives you all different kinds of options. So here, let's say, for example, I take my DF, I remove measurement and value, so I'm just left with my IDs. I call distinct, and then I create a new column, X, which is filled with NAs, Y, which is filled with NAs, and Z's, which is filled with NAs. So it gives me, takes my, what were my unique IDs from here and fills in 3 random measures. Why might you want to do this? I can't think of a typical use case that you would want to do this, except for, say, for example, you wanted to create a new data set with just your individual or unique individuals. Really what this is exemplifying is the different ways that you can go about achieving different goals. So either you can select the columns that you want, or you can drop the columns that you don't want. You can use distinct to find the unique combinations of something, and then mutate to create new columns. So now let's take a data set that is on patient experience. And as you can see, it has a variety of different metrics and measurements. It has different organization names. It's a relatively complex data set. Let's say, for example, we wanted to look at the data set where we have unique combinations of a certain measure and the measurement title. So let me, so here is our measurement CD and our measurement title. This is going to be the measurement title is the name of the specific measure. This is the actual value for that. I'm going to pull up the full data set so you can see. So here the CHAPS GRP1 gives us the CHAPS for MIPS SSM. Getting timely gives me a very long title. So for example, we might just want to know what are the unique combinations of our measure CD column and our measure title column. And this will give us that. So it tells us that we just have 1, 2, 3, 5, 8, and 12. And these are what the associated names or titles of each of these measures are that appear within our data set. We create a new data set where we take the patient experience, pivot it wider. So we'll take the names from the CD and then the values from the value column and create a new data set that has our organization, what our measurement title is, and then what all of our different sort of subcategories are. What you can see in this setup is because our measurement title and our CD were basically inherently tied to each other. GRP1 only appears with a particular title, so it produces a bunch of NA values across this data set. So we could try pivoting it wider, slightly different. where we say our ID columns come from, start with organization, so that all of these two organization columns are things that identify what our individual sort of identifiers are. Our measures come from the CD rate, and well, we end up with this is a slightly different data set that gives us, I'm just going to save it so it's easier to print. Just call it X again. So I can call it X. Now what you can see is that it was very similar to before, but instead of having NA, 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 NA across all of these, it is categorizing, or it's creating the columns for each of these measures where I grouped them by the organization columns, meaning the individuals. So like, for example, if this was different university hospitals with certain organization numbers, I can say I want to group all of the data by these and to fill in the columns with those values by that organization. Now, you might ask, well, what if I have multiple values of the same, say, CHAPS GRP1 for the same organization? And if you run this code in that situation, it will give you a warning message. And normally what it will default to is a count value. It will just tell you the number of times that combination occurs. So if it occurs twice, it'll tell you twice. And then if you get a column of all twos and ones, and you're like, those aren't the values that I was expecting, then it would likely be because you have multiple combinations of organizations with the same value. So when it doesn't know and there isn't a one-to-one relationship, pivoting to the wide format for a particular column and row combination, it will usually give you a warning and then just default to the count number. Okay, some general quick import things. So one is using, we use read.xlsx or read, no, sorry, we use read_excel for loading in Excel data. Your exam data is a CSV file or a comma separated file. You can read CSV files using the read_CSV file. You can provide so then here's where you would provide the link to the CSV data on your hard drive. But if some of the data is actually online, you can actually ask R to go and find it online and load that data for you from an online source. However, if this was something in your working directory, you could specify a file path and read the CSV. So for your exam, just as a quick start, it'll be test1.csv. So here you would make sure you would work in the right working directory, and you would, to load your data, to read CSV. It's a test1.csv. If you were in the correct working directory, you would call df is equal to read CSV, and this would load your data set for your exam. Say, for example, you have different formats for NAs and you want blanks to be scored as NAs. You can specify that I want different value, like different readings of, say, N/A, or missing values to be specified as NA. There's a variety of arguments to read_CSV that will dictate how it reads in CSV files. And it's the same true for Excel files. You can have a variety of different things that will specify how your Excel files are read in. We also have helpful functions called rename. So if you wanted to rename your column names, you could say students, which we'll go ahead and pull up what does the students look like. It has student space ID, full space ID, favorite. As you can see, these are all over the place and there's no consistency in the naming style, which would make it crazy and wreak havoc on your code. Also, we definitely know that we don't like spaces between our names. So these are things that you'll want to clean up. So say, for example, I want to change student underscore ID to student underscore ID, or sorry, student space ID to student underscore ID. I can pass the student's data frame, rename them, and it will go ahead and rename them for me to student ID and full name and leave the rest. But this means that if I have a long data set with a bunch of different variables, I'd have to manually go through and rename all of them. And then that's where the janitor package comes in that we loaded at the beginning. It has a function called clean names. And what it automatically does is it takes all of the names of our columns and changes it into snake case. So it is a relatively smart function that was able to look at, remember, this data set that has meal with a capital P, all capitalized, a dot, a space, and it automatically figures out how it wants to label these columns for you and does it in an all new and consistent format. So it's a very helpful package if you're reading in data sets from random people that have all crazy names, or if you, for some reason, cannot figure out how to keep easy data names for your current research, or say, for example, maybe you're taking this class after you created a really large Excel sheet with a whole bunch of different column names and you just can't be bothered to go back through it. The janitor package can help you with that. So I can take my variable, my data set students, I can pass it to janitor to clean up all of my names. And then I can say meal plan is a categorical variable. So in R, we call it a factor. A categorical variable called meal plan. So then it goes ahead and gives me my categorical meal plan, lunch only, breakfast, etc. Here is that n/a that we were talking about before. If I would have read in my student data with this one, so say, for example, I could change students is equal to this, where it reads this in and automatically converts the NA for me. And then I rerun this. It reads that n/a as appropriate NA. So you can tell the difference that before it was reading it as essentially the letter n/a, but now it's reading it as a missing non-applicable value rather than as being a category n/a. If you're in control over your own data set, if something is missing, I would always just leave it blank because then it will read in blanks automatically as NA for you. But if not, then specifying N capital A is the way that it will automatically read those as NAs. So then lastly, now that we have this, we can do a whole bunch of different things. So say, for example, we want to look at our age category. And here we have an annoying, someone wrote in 5 instead of giving the letter 5. So if I look at what is age, it's actually being read as a character value rather than a number, when obviously age should be a number, 4, 5, 7. And then because of this FIVE, it doesn't recognize that as an actual number. That's not too hard to change. So I can take my student data, clean my names, and then create a new column, meal plan, which is just replacing my prior meal plan, but as a factor. But then I can also replace my age column by running parse number. So remember, parse number was what we used to pull out the 1, 2, 3, 4 from the week 1, 2, 3, 4. I can do an if else age is equal to 5, put in 5, otherwise keep the same age, and then parse that number so that it'll see this new 5 and convert my column into a numeric column of all different values. So if I now call students, we can see that my now age column is now all numbers. My prior 5 is now converted into a 5, and it's now considered a numeric column versus before. So other simple tools to help clean our data sets in various ways that may not come to us clean, or might be data input mistakes, all different ways to help clean those data sets and prepare them for analysis. So, have any questions on your exam? Don't hesitate to reach out. Otherwise, that will conclude what you'll be working on this week. So, going through these lessons and then working on your exam and turning it in by 11:59 p.m. on Monday. If you have any questions, don't hesitate to reach out. Good luck, and I look forward to reading your exams.